Hey everybody. So what we're doing today is writing some more unique quadratic functions. We started this last week and there seemed to be some issues with choosing the forms and how to solve for A and then eventually get the function rule. Hey, so what we're going to be doing is that for the points given, determine the best form to use. The forms are right here just for reference, and find the function rule. So we're going to be plugging in everything except for, of course, x and f of x. That way we can graph the function and see what it looks like. So example number one, we are going to try to write the function rule that has a quadratic that passes through a root at 3, 0, a point at 2, -9, and has an x-intercept at -1, 0. A lot going on here. Now, I just separated these things because I want to make it very clear now that roots and x-intercepts refer to the same thing. It just refers to a parabola crossing the x-axis. That's why the y value here is 0 on both. So these are called intercepts, roots. They also are commonly referred to as zeros and solutions. So if you hear the word solution or zero, root, x-intercept, it's all referring to the same thing. So anyways, that being said, if we have x-intercepts, those are very easily, or let's actually go with roots because that's what our formula is saying here. If you have roots, use factored form. If we have roots, we can plug in those values into factored form, solve for A, plug everything back in, and we would have our function rule that has all of these key features here. Okay, so again, what are we using? We're going to be using factored form. We're going to be using factored form. And how you want to do this is plug in these points that I give you, or these key features. So for factored form, I know that f of x is equal to a times x minus the first root times x minus the second root. So these points that are given here, it gives us a lot. This is the first root, the 3, the x value right here. That's how you'll get root number 1. The point is going to give you two things. The point, just the arbitrary point, that's just telling you that if I plug in 2, this function is going to spit out a -9. When I plug in 2, so when I replace this right here with 2, the function's actually going to spit out -9. So hey, the -9, maybe I'll just write it off to the side here. So the -9 is the f of x. F of x equals -9. The x value that we're going to be plugging in is +2. Our first root, I just looked at the first root given, it was +3. And the second root is -1 then, right here, root number 2, -1. All right, so now that we have all our points identified, let's plug them into this formula. So f of x, again, I'm going to be replacing with -9. -9 is equal to, a is the variable that I need to solve for. That's like the missing link here. Times, I do have an x value that I'm plugging in. I'm plugging in +2. And then I'm subtracting the value of the first root, which is 3. Close my parentheses, open up the second one. Now I'll plug things into this factor. Again, the x value is 2. I'm going to subtract -1. So just think about that for a second. I am subtracting -1. Now, another way to think of that is if I'm subtracting a negative, if I'm getting rid of a negative, essentially, I'm really just adding it. So I'm not going to write this as 2 minus 1 or 2 minus -1 or anything. I'm just going to rewrite this as 2 plus 1, just like that. All right, so then now that I only have one variable, it'll be very, very, very easy to solve for it. So I've got -9 equals, I'm just doing some simplifying over here, -9 equals a. Hopefully you can see the difference between my 9s and a's. Anyways, 2 minus 3 is -1. 2 plus 1 is +3. I'll keep on simplifying this. So a times -1 times 3. Very easy way to rewrite this would just be 3 times -1 is -3, and then multiply it by a. So one last step to solve for a here. I'll divide by -3 on both sides. And I get +3. 3 is equal to a. Now I'm not done yet. I want to find the actual function rule. But again, I needed to solve for a first in order to do that. So now let's plug everything back in and get our final solution, the actual formula, quadratic formula that's going to pass through all 3 of these points. So let's just plug things in. I've got f of x equals my a value of 3, x minus our first root of 3 times, I'm just going to do x, I'm not plugging in like an actual input, I'm going to use x. I want any value to go in here. Anyways, x plus 1. All right, so what this is saying is if I plug in 3 into this function, if I plug in 3 for my x values, it's going to spit out a 0. If I plug in a 2, as we already did up here, it's going to spit out a -9. If I plug in 2, it's going to spit out -9. And then here, if I plug in -1, it's going to spit out a 0. So that is all well and good. Put a box around this thing, and that's it. That's your function formula for all of these features here. All right, let's move on to the next one. Number 2, the axis of symmetry is at -4 divided by 4, and the y-intercept is 0, -6. I think the easiest way to do this one is going to be in standard form. If it's giving you a y-intercept, you know that the value of the y-coordinate here is literally just equal to c in standard form. So we've already got this. And actually, given the axis of symmetry, you're going to be able to find the value of b and the value of a pretty easily just by thinking about it. So again, what are we going to do for this one is standard form. When you're given a y-intercept, axis of symmetry, it should be pretty easy to plug this into standard form. Let me write it out real quick. Standard form. Standard form. Okay, so for standard form, like I said, the y-intercept is going to give you the value of c. We already know that value on the end. Since you can't see the function anymore, I'll just rewrite it for you. F of x equals ax squared plus bx plus c. Standard form of quadratic. So axis of symmetry, how you find the axis of symmetry from standard form, I did a video on this a while back. You find the axis of symmetry, so I'll just put like axis of symmetry. This is a formula that you're probably going to want to memorize, honestly. The axis of symmetry, it's equal to -b divided by 2a. -b over 2a. All right, and so the goal is we're going to replace the values of a and b and c with what they're equal to in order to, like have these features. So the axis of symmetry of -b over 2a, and it tells me up here that my axis of symmetry is -4 divided by 4. All right, so just by thinking about it, what then would be the value of a? What would I multiply? So I got 2 times something to give me 4. 2 times something that gives me 4. So what would that be? Of course, that would be a +2. A is equal to 2. And then b is equal to, just look at the top here. So I've got negative some value. When I look at my axis of symmetry, it's -4. So what must have been plugged in for b? +4. B is equal to 4. And then again, c is just the value of the y-intercept, or the y-coordinate of it at least. And the y-coordinate here is -6. So by far the easiest one that we're going to be going through today. The standard form for this function, the standard form for that function, it will be f of x equals 2x squared plus 4x. You see what I'm doing? I'm just replacing a, b, and c with whatever we found down here. Minus, I'm not adding this c, well, I'm adding a -6. So we're just going to write that as -6 here. So that's our function rule for this question. That's the formula for this question, or the function form. Awesome. So our last one, a little bit different. We've got a maximum point at 4, 3, and it passes through the point 0, -5. So you probably remember that if the x value is 0, that's giving you the y-intercept. When the x value is 0, it gives you the y-intercept. So we have the y-intercept, but if it's giving you a maximum point, the way that I want to solve this one is the vertex form. So a maximum point or a minimum point, that is also known, this right here, maximum or minimum, that is also known as the vertex. Maximum and minimums are vertices of parabolas. So we have a vertex, and we know this point that it passes through. So if you see this situation, I would go ahead and use vertex form. I know it's giving us the y-intercept, but knowing how to plug things into vertex form is going to be really helpful to you. So again, we're going to use vertex form. We're going to use vertex form. Vertex form. And vertex form is defined as an output variable. So how you really want to read f of x is it's like the exact same thing as y from back in algebra 1. We plug something in, and this is what gets spit out. So like, I know you remember y equals mx plus b. We have a slope, a y-intercept. You plug something in for x, and it spits out your y value. So all we're really doing in algebra 2 now is replacing y with f of x. So it means the same exact thing. Kind of going off topic here. F of x equals a times x minus h squared plus k. That is vertex form for a quadratic function. Now we have quite a bit of the stuff that we need. This works a lot like the factor form problem, where we need to identify all of these variables and then solve for a. So let's do that now. Again, we have the vertex at 4, 3. So the vertex is how you're going to get the values of h and k. The vertex gives you h and k. So I would just think of h as being like your horizontal movement, your left and right, which is like an x value. So x value, the x value of a vertex is 4. And then for k, I don't know, it's like a kite that goes up and down or something. It's your y value. K refers to the y value of the vertex, and that is 3. The point that it passes through, this is going to be true for any point. We've got the x. When I plug in 0, it should be spitting out a -5. X is 0. Our function, our output variable is -5. All right, so now that we've identified the variables, let's plug them into this function and get a. So f of x, I'm replacing with -5. -5 is equal to, again, we're solving for a, so we don't know what that is yet. I do know what x is. X is going to be 0. I'm going to subtract the value of h, which is 4, squared plus the value of k, which is 3. All right, now we have everything plugged in. You see that we only have one variable left, so we can solve for it. I'll just do some simplifying first. So I've got -5 equals a times -4. 0 minus 4 is -4 squared plus 3. I'll keep on simplifying. Be careful with this. All right, hey, so like on a calculator, the -4 squared, if you type it in like this, it gives you a negative value. That's not true. We have -4 squared. This is -4 times -4. So how you do that on a calculator is to make sure that's in parentheses. I'm squaring -4, not just 4. When you type it in like this, it's only squaring the 4. It doesn't include the negative sign. So you want to put that in parentheses to actually calculate this correctly. -4 squared is +16. So I've got 16a then. A times -4 squared would be 16a plus 3. All right, almost done here. Now you got this two-step equation. You should be very comfortable with doing these. I'll subtract 3 from both sides and get to -8 equals 16a. My last step would be to isolate this variable by dividing by 16. Divide by 16, divide by 16. This goes away. Hey, so -8 over 16, you can do it on a calculator if you want, or just leave it as a reduced fraction. So a equals -1/2. Or if you rather keep it as a decimal, that's fine, -0.5. Okay, so now that we have the a value, we are ready to plug everything in. So our final function rule here would be f of x equals, all I'm replacing is a, h, and k in this point. I'm going to leave x and f of x there. F of x equals -1/2 times x minus 4 squared plus 3. That is the function rule. That is the function rule that is guaranteed to have a maximum point of 4, 3, and also pass through the point 0, -5. All right, guys, thank you for watching. Hopefully this helps clear up the homework assignment that I gave you last week, and I do appreciate you for watching. Thank you. Bye-bye.